Alright, this should work. So, I'm going to prove the addition rule of differential calculus. And the addition rule tells me that f of x is equal to u of x plus v of x is equal to or the same as f prime of x, which is equal to u prime of x plus v prime of x. So, first I'm going to apply the differential quotient, which tells me that f prime of x is equal to the limit of delta x approaching 0 of f of x plus delta x minus f of x over delta x. So I'm going to plug in my u of x and my v of x into the differential quotient. So I end up with f prime of x is equal to the limit of delta x approaching 0 of u of x plus delta x plus v of x plus delta x minus, then bigger parentheses, u of x plus v of x over whole thing over delta x. And I can now change the sign within the parentheses to remove it. So it actually becomes the limit of delta x approaching 0, u of x plus delta x plus v of x plus delta x minus u of x minus v of x, the whole thing again over delta x. And after I've done this, I can now rearrange. So I have this down here, which is the f prime of x is equal to the limit of delta x of u of x plus delta x minus u of x plus v of x plus delta x minus v of x, and again over delta x. And what I have right now is actually two different functions. I have the u of x plus delta x minus u of x on this side, and then I have the v of x plus delta x minus v on this side. And actually both of them are over delta x. So I can now rewrite it as this, which is again f prime of x is equal to the limit of u of x plus delta x minus u of x over delta x plus the limit of delta x approaching 0 of v of x plus delta x minus v of x over delta x. And this here is the same as u prime of x, and this here is the same as v prime of x, which I have now proven that f prime of x is equal to u prime of x plus v prime of x. Thank you.